Okay, so now we want to continue talking about how can minerals be metamorphosized in a metamorphic rock. And so this is another way called a pressure solution. So notice, by definition, we need to have a solution for this to happen. So this is going to happen when water separates minerals. When the two minerals are being pressed together, they may have a chemical reaction at the point of contact, allowing ions to migrate. So this is going to be caused by pressure. So you have to be pressing the minerals together, and you need a solution. So that means you need some kind of a fluid, something that can flow. So normally it's going to be water, but it doesn't have to be water. It can be other fluids can also cause this to happen. So as you squeeze these things together, chemical reactions are going to take place. The chemicals can separate into ions. So for example, we talked about calcium carbonate. So calcium carbonate was the chemical formula for calcite, which was the mineral that's found in limestone. So if you take calcium carbonate and you break it apart into the calcium and then the carbonate, you have just created charged ions. And then what can happen is those charged ions can go into solution and they can move off somewhere else where they then can cause other chemical reactions to take place. So our final way of metamorphosizing minerals is through plastic deformation. So this happens when a rock is going to behave like a plastic, meaning it's going to be able to flow, and its minerals can change shape without breaking. And so this is going to be caused by heat and pressure. So if you look at the original picture there, on the left, you see that those are sand grains, and then we're going to apply heat and pressure to the sand grains, and you can see how they have reoriented themselves. And notice that they did not change chemically, but they did change their shape and size. Okay, so let's take a break, and when we come back, we're going to talk about how are metamorphic rocks classified.